This video is part 2 of the Chapter 10 review. And in your homework, problems number 16 through 30 in the Chapter 10 review on page 477, your homework will consist of problems that basically ask you to find the area of a regular polygon, which has a formula of A equals 1/2 the apothem times the perimeter. Some of the problems also ask you for ratios, right? The ratios of the perimeters or the ratios of the side lengths, which is your scale factor, or the ratios of the areas of two figures, which is a squared to b squared. Okay, so, and there are other videos for our assignments that focus on those if you need extra help after this video. Okay, so before we get started on examples that use those formulas, I just want to go over number 16 with you and give you a little hint here. They said that you are to find the area of a trapezoid whose height is 6 meters and whose base, one base, is 3 times the other. So I labeled the short base x and I labeled the longer base 3 times the short base, or 3x. And then they told us that the base is added up to 18. So I wrote an equation for that. The other way that you can think about it is that base 1 plus base 2 equals 18. So that's the hint I'm giving you, and I'm hoping that you guys can solve that problem. All right, so now we're going to move on to finding the area of a regular polygon, and this time we're going to find the area of a polygon that doesn't give us a 30, 60, 90 triangle, where we have to use a little bit of trigonometry. On your homework, you will have shapes that will result, some of the shapes will result in triangles that are 30, 60, 90, or 45, 45, 90, and you will have some that do not. So I'm going to walk through one that does not. Okay, so the very first thing we're going to look at is we're going to find the area of a regular decagon 3 different ways. We're going to find it if we were given the perimeter. The second time through, we're going to find it if we were given the radius, and the third time through, we're going to find it if we were given the apothem. All right, so the very first thing I do is I attempt to draw a decagon, which I did, and I am telling everybody that it's regular by these marks on each of its sides. And then I divide it, I put a mark in the center, and I draw the radii out to each of the 10 vertices. And it divides my object into 10 equal triangles. And then I would need to find the measure of the central angle in the middle. And I know that when I draw a circle, I have 360 degrees. Well, I'm taking that circle, and since I divided it into 10 equal triangles, I'm dividing the 360 into 10 equal pieces. So each piece has 36 degrees. So each one of these angles is 36 degrees, every single one of them. All right, so let's get started on the very first one. We're going to find the area of this decagon if the perimeter is 10. So we're going to use the formula A equals 1/2 apothem times perimeter. And we were already given the perimeter. So really, all we have to find is the apothem. So how are we going to do that? Well, the apothem is a line that's drawn from the center to a side, to the midpoint of a side, and it splits this triangle in half. So I'm going to draw one of those triangles, and I'm going to draw the apothem in because it happens to be the altitude of our triangle. And because our radii are congruent in a regular polygon, I have an isosceles triangle, and that altitude splits the base in half. And I need to find one of those sides. So what do I know so far? Well, I know that this whole angle is 36 degrees, so when I split it in half, it's 18 degrees. I also know, since I was given the perimeter, if I count up all 10 sides, I get 100, so each side must be 10. So if I split the 10 in half, because my base or my side length is 10 and it gets split in half, I have a nice triangle. where now I can find my apothem right here. So what do I have here? I have the opposite and the adjacent side, which happens to be tangent. So the tangent of 18 degrees equals the opposite, which is 5 over the adjacent. So when I multiply both sides by a, these a's reduce, and then I'm going to divide both sides by the tangent of 18 degrees. So I get 5 over the tangent of 18 degrees. That's my apothem. So now I'm going to have to plug my apothem into my formula. But before I do, I'm going to go ahead and reduce the 2 and 100. So I get 50 times a. So now when I plug it in, my area is going to be 50 times 5 over the tangent of 18 degrees. And that's going to equal 250 over the tangent of 18 degrees. All right, so that's how you would do one of these problems if you were given the perimeter. So now let's talk about if you weren't given the perimeter. Say you were given a radius. What is a radius in this picture? Well, I'm going to erase this little equation here that I used to find the central angle. The radius goes from the center of my decagon to one of the vertices. So my radius is one of these triangle side lengths, and we're going to label that 8 because that's what they told me. So for number 2, we're still using our formula. A equals 1/2 the apothem times the perimeter. And I don't have either the radius or the apothem or the perimeter. So I'm going to go straight to drawing one of my triangles. I'm going to drop the altitude down. I'm going to label this angle right here as 18 degrees because it's 36 divided by 2. And then I'm going to put my radius in. And remember, the radius goes from the center here to one of the vertices. So this is my radius. And I need my apothem. And I need one of my side lengths. I'm going to call it x. So how do I find it? Well, I have my hypotenuse, and let's find the apothem first, and the adjacent side. So what's adjacent and hypotenuse? That is the cosine of 18 degrees equals adjacent over hypotenuse. So when I multiply both sides by 8, I get an apothem of 8 cosine of 18 degrees. So now my formula looks like 2 times 8 cosine of 18 degrees, and we still need our perimeter here. So I need to find x, and remember when we drop that altitude down, it splits the base of my triangle in half. So when I find x, I'm only going to be finding half of one of those sides. So again, I have the hypotenuse, but now x is the opposite side. So opposite and hypotenuse is the sine of 18 degrees equals x over 8. So when I multiply both sides by 8, I get x equals 8 sine of 18 degrees. So now when I plug that in for p, I get 8 sine of 18 degrees. And when I reduce one of those 8's to 4, I get a final answer of 32 cosine of 18 degrees times the sine of 18 degrees. And if you want to, you can plug that in your calculator if they ask you to approximate your answer. All right, so now how do we do the same thing if we're going to solve and they give us the apothem? And in this case, they're telling us that the apothem is 7. All right, so in my picture, where would the apothem be? Well, let's get rid of the 8. All right, the apothem is going to be from the center to the side, and it's going to hit the side in a right angle. So again, I am going to use a equals 1/2 apothem P, and I know my apothem is 7. I don't know what P is, so I'm going to draw my triangle again, and I'm going to drop my apothem down. I know my apothem is 7, and I need this side here. And remember, when I drop down an altitude of an isosceles triangle, it splits the base in half. This angle is 18 degrees. So what do I have here? I now have opposite and adjacent, so it's tangent again. The tangent of 18 degrees equals x over 7, and when I multiply both sides by 7, I get x equals 7 tangent of 18 degrees. So now what am I going to do? I'm going to plug, well, I have to calculate the perimeter first, so that's only half of one of the sides, so a whole side is 14 times the tangent of 18 degrees. But I have 10 sides, so the perimeter is going to be 10 times that, which is 140 tangent of 18 degrees. So I'm going to replace my perimeter with 140 tangent of 18 degrees. And when I reduce that, I get 70. So now when I multiply everything out, I get 490 times the tangent of 18 degrees, and that will be my final answer. You can always plug that in your calculator. So let's go and take a look at the ratios. All right, so I'm going to draw two pictures. I'm going to draw, let's see, I'll draw a little kite here. Beautiful. And then let's draw a bigger kite here. And on this picture, these are congruent. All right, those are my kites. So what would you say if I gave you, let's just say this is 2 and this is 7. What would be the ratio, the scale factor ratio? The scale factor would be one side to the other side. So we would have a scale factor of 2 to 7, and we can write it as 2 over 7 if we want. Okay, so if this is 7, let's just say, let's say this is 15, and this is x. All right, so scale factor is 2 to 7 or 2 over 7. The perimeter ratio is the same as your scale factor. It's 2 to 7 or 2 over 7. And then the area ratio is just these numbers squared. We're going to square this and this. They are our A and B. So it would be a 4 to 49. And if I wanted to set it up as a fraction, I could, 4 to 49. So let's go ahead and solve for x in this picture. All right, so we're going to set up a proportion. I know that my perimeter ratio is 2 to 7, and that has to equal 15 is the larger number, right? It's on the larger figure, so it's going to match up with the larger figure, the larger number here to x. And then all I'm going to do is cross multiply. So I get 30 equals 7x, and when I divide by 7, I get x equals 30 over 7. All right, so what would happen if they asked us for the area? Let's just say they gave me the area of this one to be 10. What would the area of the other one be? Well, I'd have to set up a scale, a proportion again. I would use my area scale factor now and set up 4 over 49. So the area of the small guy is 10. What's the area of the large object? And I'm not going to have enough time to finish this, but you could cross multiply and finish that. And that's it. If you have other questions, you can always refer back to other videos I've made.